ఓకే. సో ఈరోజు మన ఇంట్రడక్షన్ ప్రోగ్రాంలో ఐతమ్ కాలేజ్ మెకానికల్ డిపార్ట్మెంట్ ఫ్యాకల్టీ దుర్గా ప్రసాద్ గారు, ఆయన గురించి తెలుసుకుందాం. సార్ నమస్తే అండి.
గుడ్ ఈవినింగ్ సార్.
సార్ చెప్పండి సార్, మీ గురించి, మీ ప్రొఫైల్ కానీ లేకపోతే మీ ఎడ్యుకేషన్ సిస్టమ్ కానీ లేకపోతే ఇక్కడ చేస్తున్నారు.
ఓకే, ఐఎమ్ డాక్టర్ Durga Prasad.
ఓకే.
I have completed my B.Tech in this college only in AITAM Institute of Technology.
ఇక్కడే చదివారు? ఓకే.
ఇక్కడే సార్. So I am 2010 passed out.
ఓకే.
So all my teaching staff are still here, like C.J. Rao sir, Professor Srihari sir, all faculty are still here.
ఓకే.
And I am very lucky to have done my B.Tech here.
ఓకే.
We have very excellent teachers. Okay. So it has given me a great opportunity to build my career and to see greatest things in my life.
Okay.
So after completion of B.Tech, I have worked in Andhra Pradesh Productivity Council, APPC. So during that project, my work is that we have to visit so many companies and we have to find out what's the main reason behind the decrease in the productivity. Like in the Nippo batteries, they are producing nearly 1000 batteries per minute.
Okay.
So but during the production, they are getting only 500 to 600 batteries.
Okay.
Due to manual errors, machinery errors. So we have to find out what's the main reason beyond that, and we have to increase the productivity of the process.
Okay.
So we have worked in the Nippo batteries, Vanbury pharmaceuticals, and majorly our India's biggest pharmaceutical is Indian Immunologicals Limited. So we have worked there and we have find out so many defects, and we have suggested them so many things that how to improve the productivity and how to improve the efficiency of the organization.
Okay.
Later, I have moved to Nagarjuna Construction Company, one MNC company. So I have worked in NCC for 1 year in Asansol. During that time, my role is that I have to inspect the welding. So they are constructing the steel plant. They are constructing a steel plant of a huge capacity under the SAI, Steel Authority of India Limited. Okay. So I have worked there, and my work is that I have to look after the steel structures, okay, whether the quality, how the welding is going on, whether they are placing the goods. Exact materials there or not.
Okay.
So during that time, I have got more attracted towards the welding. Okay. So how the welding was affecting the steels, what's its main role. Okay. So I have been very keen in that area. Okay. So that interest has been driving me towards the higher studies.
Further studies. Okay.
Further studies. Okay. So due to this reason, I have taken the GATE classes for 4 months. And I have got a seat in NIT Agartala for M.Tech in the manufacturing technology. So there also, as per my interest, I have done the work on friction steel welding of aluminium alloys. So that is AA6061 alloys. Those are mainly used in the aerospace. So because those are very lightweight, so we are using friction steel welding to achieve better results than the normal conventional welding process. Okay. So we have done work under the guidance of Professor S.C. Saha. He was the director of NIT Agartala.
Okay, okay.
Later, I have moved to IIT Guwahati for my PhDs. There, I have worked under Dr. Manas Das and Dr. Sukhmay Pal. And there also, I have continued my further studies in the welding only.
Okay.
So, there my topic is that actually in welding process, what happens in the normally in TIG welding or conventional weldings, wherever you have seen, from the electrode, the arc has been traveling towards the workpiece.
Okay.
So, what happens there? At the tip of the electrode, nearly 20,000 degrees centigrade will be there. But while coming to the workpiece, there will be only 1500 to 2000 degrees centigrade.
Okay.
So much of energy losses.
Right.
And as the arc has been diverging, whatever the material we are doing welding,
okay,
so there also we will be getting lesser efficiencies. So my theme is that with the TIG welding cost only, we have to achieve laser welding efficiency. How the laser has been getting the efficiency, we have to get that much of efficiency, we have to weld that much of thicker metals with the same cost.
Okay.
So we have tried and done the literature survey, and we have finally concluded that we came up with the idea that we are placing some permanent magnets around the arc, so that we are controlling the arc according to our requirements, and we have converged the arc.
Okay.
So we got the results very similar to the greater than the TIG welding, but somewhat lesser than the laser welding.
Okay.
So we have achieved up to 50% of the results.
Okay.
So why we are doing that type of things means If the heat while doing welding, the most of the people knows that the weldability will come at the side, some heat affected zones will come. If the heat affected zone is increasing, so there will be a chance of defects, so our steel structures may break as soon as possible. Okay, as the defects are increasing, as the grain boundaries are very small, the metal becomes brittle. So as a PhD scholar, we have to take care that while doing the process, we have to achieve the strength, at the same time we have to reduce the brittleness, and we have to increase the longevity of the material structure.
Okay.
So as we are engineers, we have to develop the country, we have to construct so many structures. So we have to make sure that we are protecting the structure with our knowledge. So we have to make sure that it should go for a longer times. So that is our main motto. So that's why we have conducted works on that one. And during this process also, we have developed one electromagnet with the help of the RRCat, one of the defense sector.
Okay.
So we have developed a very big electromagnet which will be producing 1 Tesla. We are producing 1 Tesla electromagnet.
There, IIT.
In IIT Guwahati only we have developed. So it will be working for different purpose. It will be, now it was working for some different purpose, not for welding, but we have developed for welding basically. So later we came to know it will be beneficial for some other purposes. So they are doing on some other topics.
Okay.
And nowadays, this is my profile basically. I am working on these things.
Right.
So I am very thankful to the college faculty and this management, because from this rural area, they gave me a chance to visit some NIT Agartala, which one is northeast. I have visited Guwahati, and during their conferences, I have visited Sikkim, Chennai, Bangalore. So I have got a lot of scope to visit entire India. And during my PhD work also, I have so many essay journals. And presently, after coming to this college, I am collaborating with my colleagues to come up with some new ideas. And here also, I have developed, our team has developed one biopolymer,
Okay.
bioplastic. You can see here. So as usually, whatever the plastics we are having, those plastics, once used, it will take some years to degrade
Okay.
into the soil.
Right.
But we have developed one biodegradable film. So this is the basic structure. Actually, so many things we have done. The students have taken the samples to the lab to conduct the further studies.
Okay. Okay.
So we have developed this one because we can use directly in the, like with nowadays the paper plates are coming with the plastics.
Okay.
So when we are giving some hot food, so it will be releasing some amount of the chemicals.
Yes, sir.
Water bottles.
Yes, sir.
So we have trying to develop one biodegradable product, so which won't affect our body. If we are storing our products, it will not affect our body. At the same time, after our usage also, we can simply throw it in the soil.
Okay.
So within a few weeks, like around 8 to 10 weeks, the material will be get degraded.
Okay.
So which will be helpful for the soil and the plants at that location.
Okay.
So we have developed so many things here. Right now students have taken to the lab.
Okay.
So in the, if possible, next time I will show the product.
Right.
And we are trying to apply one patent.
Okay.
And we are trying to start one entrepreneurship on these products with the help of the students and our management. Okay. And one small concern is that nowadays so many people are thinking that CSE is the only option. So it's not like that CSE is the only option. Mechanical, without mechanical, it will be difficult. Okay.
Yes.
See, if you want to build a mobile, you have to come to know with some printing techniques.
Yes.
You have to choose the material, what type of material you want, how much capacity or how much temperature it should withstand. Everything will be related to the mechanical.
Yes.
And so many government jobs, whatever in the ministries, Ministry of Defense, Ministry of Heavy Metals and Industries, in all the ministries, the major portion will be from the mechanical departments only.
Yes.
Okay.
Yes.
And while coming to, if you are more interested in the softwares, we are having the core softwares, AutoCAD, SolidWorks, ANSYS. The ANSYS is the best option. You can do anything, any analysis, and comms and multiphysics. You can model anything, and you can do the analysis. So many softwares are there. You can design, you can work, and if you want to do coding also, you can go, like if, as I said, ANSYS. You can do the background process. You can do the mathematical modeling, how to come up with some new models. So everything is there. So don't think that mechanical is just like only core workshops. Nothing like that. We are nowadays, we too are using the artificial intelligence. We too are using the machine learning
Yes.
in our projects. Okay.
Yes.
So it's just your motive and just your interest should be there, that you have to do, achieve something. So according to your interest, you have to choose the branch. So not according to the outside market.
Yes.
If you are having some good interest in the mechanical, come here. You can learn so many things. And if you want software in the mechanical also, we are already so many established softwares are there. You can work on it and you can give a good output, which will be helpful to the society.
Yes.
So I am very proud to be a mechanical engineering student, and I will give my contribution to the country as a mechanical engineer.
Right, sir. Thanks for sharing your information
Thank you, sir.
and the biography with us. Thank you, sir. Thank you.
Thank you.